All right, hello everybody. We're going to be reviewing chapter 1, which is exploratory data analysis for univariate data. Univariate data means one variable. What's going to be coming up next is we're going to look at two variables, but really we focused on one variable. One variable is what we focused on. We did sometimes compare multiple groups, but we were looking underneath really at one variable. So we looked at categorical variables. A few examples of problems we looked at force level of arrest. There was no hands, hands, more force, and we looked at that for three groups, Black, Hispanic, and white. We looked at that from Stop and Frisk program in New York City. We collected data in our class on your favorite elective class, whether it was art, PE, foreign language, tech, and music. Those are both examples of categorical variables. We looked at some quantitative variables, some examples we used. We collected data in the class on pairs of shoes owned. We did compare two different groups. There was data from students and then teachers, and we compared. Remember that Ms. Banks had the most with a close second with Dolan, and the teachers tended to own more shoes. We also looked at home runs per season. We compared two groups, Barry Bonds versus Hank Aaron. When you're looking at categorical data, it was important to remember to calculate percentages, especially when the group sizes weren't the same. We made bar charts mostly, and then we looked for differences. We talked about the word association. That's when two groups have different percentage of a given variable, indicating that that group has an influence on the variable of interest. One example you guys did in a practice problem was looking on the influence of anger on heart disease. So we had three groups, low anger, moderate anger, high anger, and then we calculated the percentages of heart disease. For this particular example, we noticed that the heart disease in high anger group was 4.3%, which was higher than the low anger group at 1.7%. So we said there was an association between anger and heart disease. For quantitative variables, there are 4 different kinds of plots. Box plots use a 5-number summary and show outliers, but you can't see the data values. So it's kind of summarized here, but it's great for seeing skew and outliers. Dot plots, you can see all the values and they're easy to make by hand for small data sets. And using staplets are pretty easy also, but I can see shape here and see all of the actual data. Histograms are great for very large data sets. They're great as we get larger and larger data sets to kind of summarize data. And then stem plots are great for collecting data kind of when you're out in the field, because you can see all of your data values and kind of organize it and order it easily. And here's what then the stem plot uses the actual numbers and splits up the digits of the numbers. When I'm describing quantitative data, we talk about shape. Some words we use for shape: unimodal, one peak. We're also going to look at an example of bimodal, 2 peaks. Could be symmetric, sort of same shape on both sides. Skewed means there's a tail, and the skew follows the tail. Be careful, it's a common mistake that the skew is not the peak, the skew is the tail. Uniform is the same height all the way along. Using plain language is just fine. And make sure you know any gaps or clusters of data. Outliers, make note of any possible outliers. Call them possible unless you calculate that fence value, which is Q1 minus 1.52 times IQR or Q3 plus 1.5 times IQR. Center, we describe the central tendency of the data, and we calculate either the mean or the median. And really, whenever possible, use exact measures. If you really only have the graph, it's okay to estimate, but most times you're really going to have access to summary statistics, so use them and say whether you're using mean or median. Same with spread. Don't just say about, and the range is really not the most refined measure of spread. Ideally, you are using standard deviation or IQR. Mean and standard deviation go together, median and IQR go together. Numeric summaries, so make sure you're calculating numeric summaries. Mean and standard deviation go together. Standard deviation is the average distance of all the data values from the mean. Median and IQR to go together, and the IQR is the range of the middle 50% of the data. So like I said just a moment ago, standard deviation and IQ are preferable to the range because the range can be greatly affected by extreme observations. And that standard deviation and IQR give us more of a typical range, right? Standard deviation is an average, and sort of the IQR is like the middle piece. Mean and standard deviation are affected by skew, whereas median and IQR are resistant to skew and outliers. The mean and median equal would indicate relatively symmetric data. Median greater than the median would indicate high skew or outliers, and similarly, mean less than the median would indicate low skew or outliers. Median and standard deviation are useful for symmetric data. Median and IQR should be used when you have skew or outliers. Let's look at a free response question. And I should say that these are all AP free response questions, which means they tend to be pretty tricky, or just they require a lot of detail, right, when you're writing them up, and a lot of thought. So this example, Robin works as a server in a small restaurant where she can earn tips from each customer. The histogram shows a distribution of her 60 tip amounts for 1 day of work. So here I've got, this is measured in dollars, and I've got these tip amounts. I can see it's skewed high. Let's go ahead and start the description. So Robin's tips are skewed high to the right. One possible outlier between 20 and 22.50. Notice that I don't know exactly how much it is, right? Histograms summarize the data, so I can only give a range. The median tip is between $2.50 and $5. Make sure you know how to get a median from a histogram. She had 60 tips. That means between 30 and 31 is the median. So 25 are here. That means the 30th and 31st happen right here in this second bin. And then finally, the range. Since I don't have summary statistics for this particular example, I'm going to go ahead and use the range. If I had IQR, and that would be ideal since I used the median. And I suppose I could calculate that, but it would be kind of an estimate. I know that Q3 happens right here in between 0 and 250. And actually, if I start adding them up, sorry, Q1 is between 0 and 250, and Q3 is between 250 and $5 also. So that really the IQR is kind of in this $5 range. So the range is between 20 and 22.50, and then the IQR is somewhere between 0 and $5, which is a big difference. So then let's go to part B. One of the tip amounts was $8, and if the $8 tip had been $18, what effect would the increase have had on the following statistics? So the mean and the median. This question is asking about the resistance of the median versus the mean. The mean is going to go higher because it's not resistant. The median is going to stay about the same because it is resistant. And if we go a little deeper and really think about how mean and median are calculated, I can get more detail. And so actually, so the first part is just the general, mean would increase. I answered the question. And then here, I'm going to get more detail. The total would increase $10, so the mean would increase $10 divided by 60, or 16 cents. The median would not change at all. The median generally is not very affected. For this particular example, it's not affected at all because $8 and 18 are both above the median, so it wouldn't change the calculation. Let's do one more example. Here I have the 20 student residence hall at a certain university, and it's summarizing the room size in square feet. Let's go ahead and describe it. I can clearly see a bimodal shape, and I don't see any apparent outliers. I'm going to use the output below to use specific numbers for my center and spread. So the mean room size is 231 feet, and rooms differ from that an average of 68 feet, which is the standard deviation. Notice I interpreted the standard deviation required, but just as practice to sort of solidify what is standard deviation. Part B asks me if there's outliers, so I go ahead and calculate that. I start by calculating the IQR. Q1 minus Q3 minus Q1, which is 292 minus 174, and that equals 118. Then I go ahead and calculate the fences. Q1 minus 1.5 times IQR, which I get -3, and then Q3 plus 1.5 times IQR, which I get 469. And that tells me there are no outliers. I'm going to graph this box plot. I make sure I have my axis with the scale and then the label. And then I go ahead and graph min, Q1, median, max, or Q3, max. So for exploratory data analysis, and actually there's one thing I wanted to say also here. From the box plot, I could see there's kind of this low skew. This below the median is much more stretched out. And that's also evident in my summary statistics, but where I can see the mean is actually less than the median, which kind of supports that low skew. So to sum up, exploratory data analysis, you always want to make sure you calculate your numeric summary, make graphs, describe using SOCs for quantitative data. For categorical data, you're only looking like one is bigger, one is smaller. And then make sure you think about the problem in context. All right, everybody, I hope this was helpful, and good luck studying.